In the vast expanse of our cosmos where countless stars and galaxies stretch beyond our imagination, celestial wanderers often grace our solar system, bringing with them tales of distant realms. These visitors, comets and asteroids, typically hail from the distant reaches of our own cosmic neighborhood, the Kuiper Belt and the Oort cloud. However, on October 19, 2017, astronomers detected something extraordinary, something that would change our understanding of the universe. A faint point of light, initially mistaken for a comet, was on a trajectory that defied expectations, moving in a way that no known comet or asteroid had before. This object, later named Oumuamua, meaning a messenger from afar arriving first in Hawaiian, quickly revealed itself to be an interstellar interloper, the first ever detected visiting our solar system. Its elongated shape and unusual motion puzzled scientists. Its arrival sent ripples of excitement and curiosity through the scientific community and beyond. Researchers from various fields came together, eager to study this unprecedented visitor. Oumuamua's trajectory was hyperbolic, meaning it was not bound by the sun's gravity. This path indicated that it was merely passing through our solar system, never to return. It was traveling too fast to have originated within our solar system, moving at a speed that suggested it had been journeying through the galaxy for an incredibly long time. This realization confirmed that we were witnessing something truly unique, an object that had journeyed for millions, perhaps billions of years, from another star system to our own. It was a cosmic messenger, carrying secrets from its home star system. The discovery presented an unprecedented opportunity to study an interstellar object up close, offering a tantalizing glimpse into the potential diversity of planetary systems beyond our own. Scientists hoped to learn about the conditions and materials from which Oumuamua originated. The scientific community sprang into action, aiming telescopes towards this celestial visitor to glean as much information as possible. Observatories around the world coordinated their efforts to track Oumuamua's path. Time was of the essence, as Oumuamua's trajectory meant it would only be within our observational range for a limited time. Every moment counted in the race to gather data. Astronomers around the world collaborated to track its movement and study its properties. This global effort highlighted the importance of international cooperation in the field of astronomy. They hoped to unravel the mysteries of this interstellar traveler and gain insights into the formation and evolution of planetary systems in the vast cosmos. The data collected from Oumuamua could provide clues about the building blocks of planets and the processes that shape them. As scientists continue to analyze the data, Oumuamua remains a symbol of the endless possibilities that lie beyond our solar system, a reminder that we are part of a much larger cosmic story. As astronomers gathered more data, Oumuamua continued to defy expectations, revealing a set of peculiar features that only deepened the intrigue surrounding its nature and origin. This mysterious object, first detected in October 2017, has since captivated the scientific community and the public alike, sparking numerous theories and debates. One of the most striking characteristics was its unusual shape, unlike anything previously observed in our solar system. Unlike the typical round or irregular shapes of most asteroids and comets, Oumuamua's form was something entirely different. Observations suggested that Oumuamua was highly elongated, resembling a cigar or a pancake, with an estimated length at least 10 times greater than its width. This extreme elongation was unprecedented and led scientists to question the forces that could create such a shape. This peculiar aspect ratio was unlike any known asteroid or comet, raising questions about the processes that could have shaped such an object. Was it a fragment of a larger body that had broken apart, or had it been stretched by gravitational forces during a close encounter with a massive object? The object's brightness also exhibited unexpected fluctuations as it tumbled through space. These variations in brightness were not just minor changes but significant shifts that suggested a complex rotational pattern. These variations suggested that Oumuamua was not rotating around a single axis like most asteroids but was tumbling chaotically. This chaotic tumbling added another layer of mystery, as it indicated a history of dynamic interactions. This unusual rotational behavior, coupled with its elongated shape, hinted at a possible past collision or close encounter with a larger object. Such an event could have imparted the angular momentum responsible for its current tumbling motion. The collision could have imparted the angular momentum responsible for its tumbling motion. This theory, while plausible, still left many questions unanswered about the object's origin and journey through space. Adding to the enigma, Oumuamua displayed a reddish hue, similar to the color of some comets and asteroids in our solar system. This coloration was intriguing because it suggested a composition that included organic molecules. This reddish coloration is often attributed to the presence of organic molecules on the surface, altered by long-term exposure to cosmic radiation. Over millions of years, these molecules can change, giving the object its distinctive hue. However, unlike comets, Oumuamua showed no signs of outgassing, the release of gas and dust that creates a comet's characteristic tail. This absence of outgassing was particularly surprising given its elongated shape and reddish color. This lack of outgassing was particularly puzzling, as it suggested that Oumuamua might not be a typical icy body like many comets but perhaps something entirely different. Some scientists proposed that it could be a fragment of a larger rocky body, while others speculated about more exotic origins, including the possibility of it being an artificial object from another civilization. The true nature of Oumuamua remains one of the most fascinating mysteries in modern astronomy, continuing to inspire research and debate. The unusual characteristics of Oumuamua sparked a flurry of scientific speculation and debate, with astronomers proposing a wide range of theories to explain its origin and composition. This mysterious object, first detected in 2017, has continued to baffle scientists and ignite curiosity around the world. Some theories focused on natural explanations, suggesting that Oumuamua could be a fragment of a disrupted planet or a planetesimal, a building block of planets ejected from its home system during a period of gravitational upheaval. This idea posits that during the chaotic early stages of planetary formation, powerful gravitational forces could have flung such objects into interstellar space. Others propose that it might be a shard of a shattered cometary nucleus, its volatile ices long since evaporated, leaving behind a dry, rocky remnant. This theory aligns with the observation that Oumuamua did not exhibit the typical outgassing behavior of comets as it passed through our solar system. One intriguing hypothesis, put forward by astronomers at Yale University, suggested that Oumuamua could be a hydrogen iceberg. This idea was particularly fascinating because it introduced a new type of celestial object into the scientific discourse. This theory proposed that the object was composed primarily of frozen hydrogen, a substance that would sublimate, transitioning directly from a solid to a gas, at extremely low temperatures. Such a process could potentially explain the lack of visible outgassing while still accounting for the observed acceleration. The sublimation of hydrogen could explain Oumuamua's non-gravitational acceleration without the need for visible outgassing. This would mean that as the hydrogen turned into gas, it provided a gentle push, altering the object's trajectory in a way that was detectable by our instruments. However, the existence of large, free-floating hydrogen icebergs in interstellar space remains highly speculative. The conditions required for such icebergs to form and survive the journey through the harsh environment of space are still a matter of debate among scientists. Perhaps the most controversial explanation came from Harvard astronomer Avi Loeb. Known for his bold and often unconventional ideas, Loeb's theory pushed the boundaries of traditional scientific thought. Loeb, known for his work on astrophysics and cosmology, proposed that Oumuamua's unusual characteristics could be consistent with an artificial origin. He argued that the object's shape, motion, and lack of typical cometary activity suggested it might not be a natural object at all. He suggested that the object might be an alien probe, perhaps a defunct light sail sent on an interstellar mission by an advanced extraterrestrial civilization. This light sail, a concept already explored in human space exploration, uses radiation pressure from stars to propel itself through space. While Loeb's theory sparked widespread media attention and public fascination, it was met with skepticism from many in the scientific community. The idea of an alien probe, while captivating, requires a level of evidence that is extraordinarily difficult to obtain. Extraordinary claims, as Carl Sagan famously said, require extraordinary evidence, and the available data on Oumuamua, while intriguing, did not definitively point to an artificial origin. The debate continues, with new observations and theories emerging as scientists strive to understand this enigmatic visitor from beyond our solar system.